ahead and hit record. Share PowerPoint. All right. Are you seeing a presentation view?
Yes.
Beautiful. All right, great. Okay, so I'm trying to keep my part as short as I can because there's more of the meat coming up from Isaiah and Rebecca on really what all's been happening over the last couple of months. But so as far as the HSSI goes, for those who don't know about it, it's the Heliophysics Software Search Interface. This was a NASA Roses proposal selected last year at this point. We started the project in October of 2024. As for why we need it, generic search interfaces, don't have those science-specific filters that we really need in order to filter down on the search results that we'd want for our kind of software. Astrophysics data systems interface link for software are based on software citations, which are still mainly absent from Helio publications. And why isn't what we already have good enough? For example, with our own PyHC website interface, that's very Python-centric, open source software, and only ones that we've found or have reached out to us. And there's a lot of other things in the wild that might be useful. We don't even necessarily, hit all the categories in heliophysics for software that's out there either. For example, AI/ML. We want to align a metadata structure with heliophysics needs and international standards and make sure that, it's able to be picked up by the major search engines. There's a lack of links to other important resources, for example, software to the software that you're using now, related data sets to the software, et cetera, et cetera. And thus we have the HSSI as a proposed solution. Basically, the idea is to unify software metadata with those international recommendations, improve software search capabilities, and simplify citation of software in other resources you use. It'll be one landing page to find any scientific software you might be interested in Helio, starting with, all of the PyHC packages here, which is why you've heard about it so many times if you're, a regular for the community. We'll expand out to other code and other programming languages and work to get other software categories incorporated as well. We want to create interoperable software metadata. So we've been implementing a new software metadata structure for software registration. And you'll hear a bit more about that from, Rebecca in a minute. Build a registry of software metadata in Helio with a REST API slapped on top of it. And the last bit is, what's happening here. We've been sourcing input from community meetings like this. We've presented it at AGU and so forth. So that's the HSSI, just the team there. Half of us are on the call right now. All right. So as for the actual meat of this presentation, so phase one is the first 1 to 3 months. So October to December of last year, that was really the information gathering and initial design phase. That's what's, already been completed. Get that initial input from community meetings to see what software categories aren't well represented in PyHC, yada, yada. Get feedback from AGU as well. Come up with some use cases based on all this initial feedback, draft those initial software metadata, and so forth. We forked the EMAC software, Exoplanet Modeling and Analysis Center. Joe Renaud is one of the leads for that, and he's on this call right now. And he's been helping us a lot to understand that code and, make the HSSI the best it can be. This is all ripped directly from the proposal document. So that's why the next bullet, it says, attend weekly EMAC tag-ups to ask questions as needed. It's more been like Joe's hopped in on our weekly software metadata tag-ups, and we can, ask questions that way. And then, yeah, think of some usability testing strategies that we could use in phases 2 and 3, which we're in phase 2 right now. So that's the main chunk of the proposal, the main development section. So things that, we've completed. We have the draft of a software registration interface with, intuitive names, motivation for each metadata field. And we've been really careful about which things we're giving as requirements that you have to fill out versus what are the recommended fields to fill out and so forth. We've worked with you all on the metadata structure and, getting feedback on that at various PyHC teleconference meetings. The third bullet point is what's happening right in this moment, presented at the PyHC Spring 25 meeting for review. I put it in italics, just development as needed based on feedback because we haven't done it yet. We're literally presenting right now. As far as a minimal viable product, MVP, if you will, for the HSSI, we finally have a consistent link here for it. So it's hosted on Helio Cloud. And then the source code for all of it, you can find on GitHub at that link there. The next bits are the ones that, we're still doing right now. So conducting usability testing sessions of the site itself, literally at 10 a.m. Why we're ending early, we're about to perform our first one. And we have another one happening today as well. And then just, do working updates throughout phase 2. To come is basically the finalization and wrap up, since this is only a year-long grant. Clean up the website and software registration, add a REST API potentially on the software registration interface, but definitely on the software search interface. Push the website, put the links all up on the PyHC site, and all that good stuff, document everything that needs to be documented. And then the bonus, which we already started working on, is creating a logo for the HSSI. We've reached out to a local graphic designer about that, and hopefully have something, cool coming up in the works, and perform more usability testing sessions. Design and metadata. So these are all the specifics that I mentioned will be covered soon by Isaiah and Rebecca for updates there. And that's what I have for you all. All right, didn't take too terribly long. It was a bit of a whirlwind. Let's see, any questions in the chat? Our meetings are just a group of people having existential crises. I love it. What do you mean your meetings are that? I'm getting a can't be found. Oh, because I didn't have the HTTPS. Thank you, Isaiah. But don't visit. Yes. If you're going to be one of the testers here in a bit, don't look at it just yet. But obviously people are going to see it after that point. So we'll have to get creative with our usability testing sessions. Okay. Other than that, any quick questions for me? I don't want to steal, too much of the floor from Isaiah and Rebecca. Okay. I'll take silence as you understood everything and you're mad impressed with where we're at. Okay, Isaiah, go ahead.
Okay, let me go ahead and steal a screen share here. I swear the interface changes every time I try to do this. Share screen, there we go, okay. And that's gonna be this one, entire screen. All right, are you guys seeing the
Yes.
slides? All right, perfect. So yeah, I'm just gonna kind of rush through here. I don't want to steal too much time from Rebecca. So hi, I'll be giving a rundown of the current state of the heliophysics software search interface, where we started and what we've done so far. For those of you who haven't heard from me before, I'm Isaiah Smith. I'm a computer science major in astrophysical and planetary sciences undergraduate student at CU Boulder. And I've been doing the whole academic thing kind of backwards, as I already had about 5 years of experience in software engineering before coming to school. I've been working on the development for HSI since November, along with Julie, Rebecca, Joe, and Kat, who've been the design and metadata experts behind it all. I think it's important to mention that the work here we're doing isn't starting from scratch. We're lucky enough to be able to utilize a solid foundation of the website, designed and developed by the EMAC team, Exoplanetary Modeling Analysis Center, over at NASA Goddard Space Flight Center. The template project is called Resource Discovery Interface, and it hasn't been open sourced yet, but it should be soon, so that y'all can use it if you need to. Luckily, we were able to get our hands on the source without having to wait for that to come through. And not only that, we've been working closely with the EMAC team to help get us up to speed on understanding the structure of the code base and how to best utilize it. Huge thanks to Joe Renaud, Mike Moore, Dylan Christie, and the rest of the EMAC team for their patience and understanding when working with me and doing their best to answer my endless, maybe annoying questions. Although since the required functionalities for the HSSI are vastly different from that of EMAC, we haven't been able to just drag and drop. We're repurposing large portions of the code base to meet our needs and refactoring others to be more friendly to the open source community. So here are some of the major changes to the tech stack that we're working with compared to the foundational code base, RDI. First and foremost, it was important from both a security standpoint and performance standpoint to update the base version of Python that the backend is running on. Since the server runs in a Docker container, we were reliant on a specific Docker image that was cached in the Docker repository, which had Python 3.7, which made it impossible for us to update the version of Python without creating a new Docker image. However, since we didn't have the original Docker file, that was kind of difficult. Fortunately for us, Mike Moore came through, and he had dug up some old Docker file from some deep, dark NASA software archive that probably hasn't been touched in 10 years. And that allowed us to create our own Docker image based off of it, but with an updated version of Python. This released us from our dependence on that Docker image and allowed us to use the newest version of Python 3.13. Along with this Python update, it allowed us to update our server backend, which is Django, to the newest version. This is critical for security since the HSSI is already open source. Relying on outdated dependencies would mean basically giving attackers a list of known exploits that they can use to infiltrate our server. So the only way to combat that is to constantly stay up to date as much as possible, as to not disclose any known attack vectors. We also needed a more robust form generation solution than RDI, which Django server-side form generation, which is based on templates, didn't satisfy, but implementing custom solution required developing a complex front end, which I knew would be a nightmare in vanilla JavaScript. So we've got TypeScript and ES build now for the front end. Then we were able to get the form generation behavior that we wanted, which I'll go over more in depth later. There were also other countless dependencies being used in the backends that we were able to target by doing dependency walks and update them with pip tools. So for the database design, we took an iterative approach, knowing that it would be an important foundation that most of the website's functionality would be centered around. And that's in the background here. You can kind of see a sneak peek of our database design schema. So the sort of foundational ideals that we wanted were granular tables. We knew that the tables in the database should be granular. So instead of one flat structure where a single table stores all the information about each software entry to HSI, we segment the entries into discrete bits. For example, we split apart authors, affiliated organizations, funding awards, and etc. They're all examples of these separate tables in our database that are central to that the central software table can refer to. This allows us to infer relationships between the software entries. So if you don't know exactly what you're looking for, but are familiar with some software, you can browse entries laterally. It also makes it easier for developers to submit their own tools, as it eliminates the need to repeatedly enter redundant information if it's already in our system. In the same vein, scientists will also be able to search across multiple domains. For example, you'd be able to browse software by functionality, the author, or you could filter by keywords, organizations, just any of these discrete bits of information we've split the tables apart into. And the granular design also allows some of these tables to fetch definitions from outside of our database, such as observatories and instruments from the International Virtual Observatory Alliance database, IVOA. We also have another open source repository for our own definitions that some of these tables pull from, and you'll be able to create sort of a pull request if you feel that there should be more options available to select from than what's available in the HSSI. I briefly mentioned this a few slides ago, but this is the first complete part of the website interface we have. So we thought usability testing today specifically for this feature would be good. Unfortunately, because that's scheduled for later today, we've decided to not do the live demo that was originally planned, as we don't want to show the users who are going to be doing the testing how to use the website before they are tested. So instead, you just get a little sneak peek example of the screenshot of what a sample partially filled out submission looks like. Submission form, I should say. So what this is really is what the developers interact with when submitting their software. The forms are built client-side, and they can be generated automatically based on the table structure and relationships encoded in the database and design. But the specific fields are exposed manually through Python on the server side, preventing accidental exposure to potential security vulnerability if there is sensitive data fields in some database tables that we don't want to be exposed. One reason this is important is because our database has deeply nested database structures. Since Django form generation works through Django templates, the entire form, including every HTML element and control, needs to be created on the server and then sent to the client where the browser renders it. This is problematic if you have a deeply or recursively nested database structure, since there isn't a finite set of HTML controls that can represent that structure. In our solution, in a nested field, the HTML controls are not built unless the user expands its subfield, as seen in the screenshot, which is what you see these little dark lines are here. These represent the subfields to the parent field, and they can be nested. I'm not sure if you can see my mouse. I hope you can.
Yeah, we
but cool. This not only makes it possible to represent deeper structures and forms, but also increases server performance, as only the JSON data required to represent the structure needs to be sent instead of the entire reconstructed HTML web page through the Django template system. The final added benefit of this system is that due to the fact that the forms can be generated based on database structure, it allows for much easier refactoring if any changes are made to the database design, which we have done a few times. So it will be helpful in the future. And yeah, just a final note about the server here. We do have it publicly hosted now, thanks to Sarah Rourke at the Helia Cloud, Helia Cloud hosting place. So you can access it at the link listed here. I do want to say though that if you're one of the volunteers who's doing usability testing, please don't visit the website. We want you to go into it blind. For the rest of you, feel free to follow the link. I should warn though that the landing page is not representative of the finalized website. It's kind of more pretty much just like what Emac had, and we haven't really changed it much. And because it hasn't been adapted to our specific database, none of these features on the side here work, like the filtering and the search, quite yet. We just have basically these packages pulled over from the PyHC website. And but yeah, you can follow the submit a resource link up here. Again, if you're not doing the usability testing, to see the forum that I was just talking about. And if you have feedback on that, feel free to reach out to us. And anyways, that's it for me. Thanks everyone. I hope it was a good explanation and answered any questions. But if you do have any questions, let me know.
All right. In the interest of time, if you have questions, throw them in the chat. Also, yes, I see clapping. Thank you, Isaiah. Yeah, if you have questions for Isaiah, throw them in the chat. Do that there, and we'll go ahead and move on to Rebecca's presentation and then get into the working sessions.
All right, here we go. Okay, you should be seeing my slides and now in slideshow mode. Is that correct?
Yes.
Let's rock and roll. All right, so hopefully the third time's a charm. I don't know. See how this goes. So I'm talking about implementation. So we've been working for several months on the metadata design, and you're going to see some pieces of that here. This is a group effort. All right, so we've been working to incorporate some information from this community, not only from the PyHC website, but also from the last PyHC meeting that we had, particularly on the software categories, and then farming some information, if you will, from existing packages and trends that we're seeing to construct some metadata quality controls, if you will, about what kinds of terms are already used by this community, so we can merge and meld in ways that seem appropriate. A good chunk of this, and part of this is a live experiment, if you will, on my part. What can we do when developing a new interface to make the metadata curation easy? And that includes when you're entering metadata, or there are features, which there are, that we can include that extract metadata from existing sources, align it with the standards, and all of this behind the scenes. So to make metadata entry a lot easier on the people actually doing it. All right, so one thing we've been working on that is going to be built behind the scenes for you is that the metadata that you enter into the HSSI, however minimal that is, will be expanded on through existing resources and then formatted in ways that increase your findability. So for instance, extracting metadata from GitHub, as you'll see in a moment, any additional input a given software developer gives through that submission form, aligning that metadata with existing standards and formats. In this case, you'll see code meta being flown around, which is gaining momentum towards being an international standard for how to express software metadata, and particularly aligned with the schema.org. So basically how internet search engines work. And the idea is to give this metadata back to you to make your landing pages more findable. And there's some interesting collaborations building internationally on this. So there's some promise hanging in the air, if you will. And of course, this is going to be an iterative solution. This is going to be back and forth, not only with this PyHC community, but the larger heliophysics software community. So without flashing JSON at you, which would probably make most anyone run for the hills, I'm going to try to tell the story with pictures. So we'll do it this way. So what you see here on the left is a diagram you're going to be familiar with in the next 20 minutes or so, but it's an interactive picture of the main categories and the subcategories of software functionalities that we pulled from the survey we did last fall at this meeting. The picture at the bottom is a screenshot from the main page of the HelioData website. That should be, if it's not already launched, it's launching in the next few weeks. So that's exciting. And the idea is to have connections and useful connections between the software of the heliophysics community and the data of the heliophysics community so that we can increase usability for our research community, research and mission community across. And we're putting all of this input and incorporating this information into the existing software stack of EMAC. And these are the adaptations that you saw Isaiah talking about that are in process. However, we need your feedback. Remember, I said this is iterative, so this is a chance for us to pull feedback from you, and that's the purpose of this session. So things that are in the works to make metadata entry easier, as in you have to enter less, but you get a ton out of it. So for instance, automatically extracting metadata from DataSite. Well, what's DataSite? So let's take the popular assumption that you have code on GitHub and you use the workflow from GitHub to Zenodo to make a DOI, a version specific DOI for your software. And for the more advanced packages, you may have an automated workflow that automatically creates version specific DOIs for each major release. You may even have a Zenodo JSON, although that's not necessary for that to happen. So assuming this workflow, which seems to be increasingly popular, and even assuming that you have a DOI for your package at minimum, by entering your DOI eventually, not yet. Eventually, what we're going to have is when you enter your version specific DOI or any type of DOI for your software into our interface, it will automatically extract the information that's available from that metadata record associated with the DOI and then auto populate that into the metadata record. So you don't have to go fetch all the information again. And then piping those things into HSSI. We can do the same from GitHub, and there's a really cool tool that's been developed by one of the leaders of Code Meta called SumFweiter. Maybe this is German for something intelligent. I don't know these things, but this is a really capable tool that we found that can pull a whole long list of information if it's in the metadata for your GitHub repository. Um, this I am told this also works for GitLab, so that's going to be, assuming that that is true, that's going to be really nice. So we are collaborating with these people in the coming weeks and months to incorporate that into our interface and have some feedback back and forth. So simply by putting in the link to your GitHub for your software repository, a whole bunch of information can be extracted, which means you don't have to go find it for us. The tool can do it for you. We're also really interested in making associations between data and software easy. However, we understand that a given software package, particularly those that are increasingly popular, provide functionality for a large number of data sets, and nobody wants to enter all of that information into a form. So our guess is that connecting to missions or observatories instead of individual data sets is the easier thing to ask. And taking a step farther from that, as in we don't want you to have to dig up the official full name of the mission to be able to make that connection. We want to have some sort of feature similar to the Unified Astronomy Thesaurus interface here, screenshot on the right, where you start typing the mission name and matching items pop up in a drop down list. You click that mission name and automatically behind the scenes, a whole bunch of metadata gets entered in. that you may not even know exist, such as the official landing page for that mission, or the DOI, or whatever position identifier is associated with that mission. All those kinds of things, we want to make that work behind the scenes with just a little input from that software developer. Ideally, we want this for all observatories and missions, whether or not they have a SPACE record. So SPACE is the International Metadata System in heliophysics that describes data, describes missions, instruments, and a couple other things. That might be too tall of a goal before the end of the funding. So intermediate goal is to at least demonstrate that this can work for at least the things in space. We'll see how that work towards that. We also want to improve findability for your software and not necessarily for the HSSA website, because the priority here is to make your software more findable and more used by the community around you, particularly those that may not know your software exists yet. So right now, took my favorite example, favorite gold standard is SunPy. Okay, no hate on any other packages. Okay, but we chose SunPy as our gold standard. We're also working on testing these things for PySpeed also. So thank you, Jim Lewis, for all of the input. But what we did is currently, so what you see pictured here are some screenshots from the Google Rich Results tool. So this is a tool that you can use to see how the Google search engine understands your web page. So here, just putting in the sunpy.org, it doesn't detect a software package. I'm putting in SunPy's GitHub page. It also doesn't detect a software package on that page, which is crazy, right? But if you take the metadata that you enter into HSSI and it goes through the magic behind the scenes of formatting and aligning with standards, and then we give you that output, then that output can be embedded into these different web pages, and then your web page will show up in Google as describing a software package, which is what you see on the right here. That is what we want to do, not only if it's your personal documentation or a custom website, but ideally also on GitHub and on the Zenodo landing pages too, although that will take more time because it involves collaboration with those larger organizations. That's our goal here. So here you see a different diagram about the same concept. So the idea is to take the metadata that we generate in HSSI based on the input and the extractions that you saw, align it with the code meta standard for the International Code Meta Standard for software metadata, align it with schema.org so that they can understand your web pages, and a couple more tweaks for Google for it to recognize the web page as a software. Give that to you, and then it increases the findability of your software package based on the websites that you have. All right, so I want to pose a question to this community before we go into some interactions here. So I've been talking the last 2 minutes or so about embedding metadata into, like, giving you, the software developers, this metadata file that then you can just copy, paste, or and maybe through some automatic functionality into your documentation pages or custom websites or those kinds of things. But I want to ask the question here. What is the opinion from this group about having landing pages on HSSI? So what do I mean by landing page? So a landing page would be something similar to the landing page on Zenodo that hosts the information about your package, or a landing page similar to GitHub that also hosts some information about your package. We wouldn't host your code, of course, that stays over there, but it would host metadata and links and those kinds of things. And in my mind, the only motivation to do this would be for us to embed that metadata that we generate into that landing page and increase the findability of your software package, versus waiting a longer time frame to have that happen on GitHub and Zenodo. Some cons to this would be, well, that would direct people to the HSSI version of the landing page, which may in some ways decrease traffic to your pages, but the idea would be they would come to this landing page, click on the link to your landing page, and that would be where they actually access the code. That's where all of those access links would be. On the other side, we could if we don't want landing pages, what we could do is try to get some funding for software developers to write a script for GitHub, write a script for Zenodo to take this kind of metadata and embed that metadata in those landing pages to direct internet traffic there. But in the meantime, I'm wondering if the HSSI landing page idea could be a temporary solution, as in maybe a 2-year thing, just throwing a time frame out there based on just guesses of how long this might take. But I wanted to get feedback from this group on this question. This will help direct our efforts on the HSSI implementation in the next few months. So this is the time to provide feedback. Of course, if you have any general questions about what the heck are you talking about, Rebecca, and and other questions like that about this presentation, now is also the time. So I'm done, and I'm hoping to get some response.
All right. Thanks, Rebecca. Do we have any flowers or tomatoes to throw at this?
I can be the field goal.
Especially looking for feedback from all the software package leads here on the call.
How much maintenance would the HSSI landing page require from the package maintainers? Like, if we update a new version, would that update automatically, or would we have to have a step in our release workflow to go update that?
What I would like to see is that anytime, like we would, to avoid pinging GitHub and Zenodo all the time. What I imagine we would do is at some regular cadence, maybe it's every week, maybe it's every month. But if you give us your GitHub link and your DOI link, that we would have a script that runs and looks for any updated information based on those, what's based on the metadata we can extract from those things. And that would be automatically populated to the HSSI metadata structure, which would then automatically produce that aligned metadata output. And that metadata output would need to go somewhere to be used to increase your findability in an updated way. So if we had a landing page on HSSI, that metadata output would automatically get updated, and it would automatically get embedded in that dataset landing page there. If that metadata were going somewhere else, that would be dependent upon external features, which hopefully would also become automated. I'm not sure of that structure yet. It doesn't exist.
Well, that all sounds reasonable, and I think that's something PySpeedS could get behind.
Okay.
What about some other packages here? We have some SpacePy, PlasmaPy, representation, a couple others.
Maybe just to get some thoughts flowing because it's a little quiet at the moment.
I think
I
John
wanna-
had just muted Sean.
Oh,
Oh.
I was about to say a lot of nothing, which is I'm going to wait until after I do the usability testing. I haven't heard anything that I would say no to at this point.
Okay.
I'm just always reluctant to say yes. I think that the broad strokes of this are pretty good.
Okay. Yeah, a lot of details to work out in the making of it.
Yeah.
So the HSSI already has that card display for every package on the main page that does display a lot of metadata, like, its keywords and its community badges, links to repo, site, etc. So how would these landing pages be materially different than just the expanded card view?
So expanded card view. I don't think we have that in Emac. We just have the cards, and
There's a little
Am I
arrow
going wrong
below
here?
each card that you can click that expands it to reveal a little bit more metadata.
Okay. Let me get the pictures in my brain linked. So click on,
There's a little arrow at the bottom in the middle.
Thank you.
Yep.
Okay, so let me choose something. Let me pick on SumPy because they're not here yet. No.
The search just doesn't work yet. Sorry.
That's right. That's right. That's right. So is it alphabetical here? No.
I think it's arbitrary.
Okay. Let me see if I can. I guess we'll go with this one. Okay. So the metadata that I would put on a landing page that's not shown here would be connections to missions that we were talking about. So if a person went to a landing page, say through some Google or Bing search or whatever, and they came to that landing page and they said, okay, I'm actually trying to build a workflow based on, because I'm using data from this mission and that mission, and this package would be great because it covers both of them. Or this package doesn't support data from this mission. Okay, so I need to continue my search elsewhere. So that would be some information. Reference publications would also be here. Say SunPy has has a reference publication for their software package. But say someone cited the software package but not the reference publication. So they would have connections to that information here too, just from the metadata. Let's see, what else would I put here? I haven't designed it yet. I will say that I wanted to get some feedback here before I really dove into that work and didn't want to waste time. But things that, let me show you something on Zenodo. That I'm gonna I'm not picking on SumPy, but I'm trying to use that as the thing I'm showing. So something new on Zenodo is that they are showing things that cite that specific version of the software package. And that's not done through Zenodo's metadata. They're calling a service to do that. Well, we could incorporate other things into this service because the Science Explorer is working on extracting software citations from publications in some really interesting ways. So that could be something that we show here on that HSSI software landing page, where we have I'm daydreaming here. Okay, so I'm throwing pies in the sky, but I'm thinking they're reasonable things to shoot for. Sorry, need a little more sleep. But the idea dancing in my head is that we would have an API set up with Science Explorer. We give them the DOI for the software, maybe a couple different version specific ones, um, and maybe all of them. Maybe that's how the API works. We shoot these DOIs at their API. We get a list of things that have cited that software, whether it's the software itself or the reference publication. And then we show that on the landing page as related publications, maybe data sets that have cited the software in some way, or other software packages that have cited the software in some way. So see some different categories there. Some other things, obviously link to the Zenodo page, as that's not currently, well, that could easily be incorporated in the card, but you hear me brainstorming here. There could be some really cool things that come into that landing page that might be more difficult to get incorporated, say, into the Zenodo page. Because, for example, the Science Explorer is definitely NASA specific and very small potatoes compared to what Zenodo typically deals with. So that might be kind of hard to convince them to do that. But there, I think I've thrown some pies in the sky.
Yeah, there you go. No, I will refrain from giving my own opinions here just to not pollute the pool, but I think that
Okay.
gives a more concrete idea of like what we're talking about. So appreciate that.
Yeah, the idea is to show more connection between that software and other pieces of research. Not saying we can do that in the next 6 months, but there it is. Well, Julie, let me know when you want to shift towards the activities.
Hearing silence from the general audience. Let's go ahead and do that. Let these ideas that you've thrown at the wall, the spaghetti at the wall, if you will, percolate.
Sure. Yeah. So I guess my action item, if you will, coming from here is to brainstorm on what we would want on a dataset landing page, and maybe that becomes a discussion on a telecon in 2 months or something like that. Um,
I just don't know if that's enough advanced lead time to figure that telecon out.
okay, we'll see what happens. But that will likely be a discussion topic coming up soon. I will make sure to do that. All right, so the activity here is we showed you some glimpses of what the HSSI interface will look like. You'll notice, well, you probably won't remember, but we did have a feedback session on software functionality categories at the last PyHC meeting, and we've worked to build a structure to represent that on the website. And you see pieces of that here. And as Isaiah said, our focus has been on more of the guts of the effort rather than the top. But now it's time to be confirming what we want in those structures for the top and propagating that down. We want to make sure we have the final feedback from this group before we start implementing this fully. So we have several different pieces here. We have the software functionalities and a couple of different categories here. So let me pull everybody to this. I'm putting the link in the chat right now. So please jump on here. Everyone should have commenting permissions. So we have a couple of different structures here, and given the number of people, it seems borderline to me, Jolie, whether we split into 2 groups or not. I'll leave that decision to you. But before before we jump to that, let me explain both activities so you know can form an opinion on which group you would want to be in or whether we sticking together. This document has 2 tabs. The first tab is simpler than the second one, but they are both critical to get your feedback on. So we have a couple of controlled lists, if you will. No definitions here, just lists of terms. But the types of things that we've imagined are useful for people to search by are here. One of them being data input or data feeds is another term for this. And here we have a list of terms. Here, here's one that's going to raise some pitchforks, and I want those pitchforks, so be happy to throw them. We are happy to receive them. But what are the common licenses used by software in this group? Operating systems, we want to keep these, want to have a list of common operating systems, but as you notice from this list, very high level terms, not like version specific or anything really down in the nitty gritty details. List of programming languages that are common in this group and supported file formats. Okay, so the goal of even having these things is so that when someone is searching here, and let's say that this category is called, what did I just say? Supported file formats. So they're working with data, say that's in HDF5 format, and they want to find some software that can pull in data from that file format, and then they can figure out more details about the internal structure of that and whether that's supported in documentation. So the idea is that they would have this in their mind and they would come to HSSI and they want to filter and show something that has the HDF5 format. Let's imagine that's the HDF5. And then the software packages that have that keyword indicated would pop up in their list. So that's how all of these lists would work. Now notice for all of these things, there, that we don't want to have an overwhelmingly long list of terms in each thing. There's some presentation ways on how to do that if the list must be long. But the idea is to try to keep these to be the most common and not necessarily comprehensive. We do have an other button, for example. Another thing is we want to make sure to include supported file formats that are more of the community standard. So we want to avoid, say, the NC dump files, the NumPy dump files. That's not really usable long term. So we want to discourage that by excluding it from the list, for example. Because they can always choose other, right? So that's the idea on this page. And the way to provide feedback here is say, well, I'm going to give a really funny example. Like, I don't think happy should be on this list because of XYZ reason. So I'm going to say in suggestion mode, this should be removed. And then I'm going to have, here's my reason why this should be removed. Okay. So that's the way you get feedback there. If you know me, I actually disagree with that opinion, so I'm not going to put myself as making that comment, right? But that's how we want feedback here. I imagine that as a group, we would talk about this for 5 to 10 minutes, try to get any discussion going that's needed there, shift to license, which will probably be longer than a 5-minute discussion, and then try to cover the other topics as well, maybe 5-10 minutes each or something like that. Probably less than that, or maybe some of this is a couple minutes in the following hour. I see time running away from us. The second tab is a little more of a complex thing to wrap your brain around, if you will, but these are the software functionalities. So let me explain this screenshot. So the link here at the top of this document goes to this. And let me show you what it looks like when you load it, because it does a funny thing. That's really cool. All right. It does the crazy dance. But the thing is that these black circles are movable. Please don't ruin my website. But the black circles are those high level categories from the feedback last time. These smaller circles are the smaller gray ones are the subcategories. And the reason I built this is so that you can visually picture the relationships between subcategories and main categories. So for instance, you see mission related has a large number of subcategories, which you see if you hover over that black circle, and that is currently reflected on the website in this longer list. You see that? But some of the subcategories in mission related are also subcategories of other fields, such as models and simulations for an instrument response, right? So that's what this particular type of website is really nice at showing. So the feedback here has multiple parts. So a couple things. Are there any major categories that you think should be combined with others? So maybe this data simulation has no subcategories right now. Should it be combined with a similar major category? Or should it be a subcategory of this new type of thing that you have an idea about? Another type of thing is, are there any subcategories, for instance, mission specific, that should have a connection removed, like one of these gray arrows? So should mission specific be a subcategory of mission related? Does that make sense? Or maybe a connection should be added. So should mission specific also be a subcategory of models and simulations? So should that connection be added? So looking at input from this group about how you would want this rearranged before we implement this and propagate this down to the metadata level. And the way you do that is similar to the other page. So here's an example. You're in suggestion mode, so you type something like, okay, I want the connection between mission specific and mission related to be removed because I think mission specific shouldn't be a subcategory of mission related, for example. So you come in here and you say, okay, remove that connection. And then here's a suggestion of how you would say you want mission specific to be a subcategory of models and simulations. You would add that connection. And if you want some sort of other rearrangement, change this thing to this new situation. And if you feel like you want to provide some more explanation or maybe justification of why this should be done, you can respond to your suggestion with a comment here. So we have 8 minutes left, Julie, which is less time than I thought we would have. How do you want to move forward with this?
We can start at least on the first tab with a couple of the tasks there, and then let's maybe delegate the rest for telecons.
Okay. How about, since the software functionality one is a bit more complex, how about we work on that for a few minutes to kind of get people's feet wet?
Okay.
All right. All right, so yeah, jump in this document on the second tab, click on this link, and let's talk. first of all, any ideas percolating? What do you have? I'll let you absorb.
Probably still just taking in what they're looking at.
That's why I wanted to give them a few minutes to understand this mess. Let me ask a question. Let's take the hot topic, MLAI. So, would it make sense to have MLAI be a subcategory of mission-related software? And potentially other categories. Yeah, go ahead, Daniel.
Hi. So just to chime in, it's kind of hard because I could see uh, machine learning algorithms being applicable in a few different areas. So you
Right.
could have a mission specific one. They have algorithms that are used in aiding data visualization. So I don't know. I am unsure if it can be singly attributed underneath this, one of the categories. You know, I think there might be some variance in different categories.
That's why I like this structure. So what I'm hearing is that MLAI could be a subcategory of mission-related, data visualization, probably also data processing and analysis,
Yeah,
right?
that's what I was gonna add.
Absolutely.
Okay. Now, if it's a subcategory, well, I don't think it would be a subcategory of servers and environments. At least I haven't heard of anything there.
I feel
Um,
like it would be more like potentially its own central node that would connect
right.
to those other blobs. Just
So
because
it could
Daniel,
be a major category and subcategories of other major categories.
yeah.
So let me try to demonstrate that. So I have editing permissions because, oh, never mind, I'm not logged in. So the suggestion would be to keep MLAI as a major category, but also indicate it as a subcategory of other things. So then that would come in here. So keep MLAI as a major category, but also add it as a subcategory of, and I'm going to leave this open. So can you come in here, Daniel, and give some space to everybody, add what major categories it would be a relevant subcategory of, for instance, the mission related, the models and simulations and so on. Can you add that?
Yeah, one sec.
Rebecca, we
And
also have a comment in the chat. Sorry, I didn't mean
Oh,
to interrupt you, Daniel.
let's grab that.
I added it from Kevin.
Data visualization could capture. Right, throw this in the document. Pull it in. So yeah, there's going to be overlap. So from the search interface perspective, someone would click the things that's in their mind that they're trying to do, and the idea would be you would want, if your package does that thing or supports that functionality, you would want that functionality to be part of your metadata so that when they search for that functionality, your package pops up. From the other side, when you're entering on the metadata side, when you're submitting this form, we can only farm so much of these things from GitHub, which you should read as not much. because the keywords in GitHub are free text. It's not from this thing, and there's only so much that we can do there. So when you're entering metadata, you would click this overall category and then click any relevant subcategories, and you would just go through and click stuff that's relevant and just go down the page like that. But yes, there's going to be overlap. We're not trying to have each category be orthogonal, because we're trying to have them at least be different concepts, if you will, like the 2D line plot versus the 3D line plot, for instance. But movies. That's interesting. Yeah, that's cool. Yes. Kevin, do you want to provide some comments and hopefully jump in the Google Doc and provide some more instruction there? I see you unmuted, but I can't hear you. Might be having some audio problems.
I just put in what I could think of off the top of my head.
Yeah.
There might be more, but
Okay. Sorry. Now I might work.
Oh, great. Go ahead,
Yeah.
Kevin.
No, I was just, I understand the overlap, that's a feature. Yeah. I guess putting in something like Power Spectra, though, is a specific example, I guess, of one set of coordinate axes and why there would be many. So if you go down that route of identifying plots with specific sets of coordinates, you could either have a lot or
Yeah. So, is there a set of specific types of plots that are, for instance, specific to heliophysics, as in
Mhm,
not generic across all of the sciences, because we're trying to
mhm,
focus on heliophysics
right?
here, but very commonly used across a large number of softwares or something like that. Power Spectra stood out to me as a first
Mhm,
guess of what that might
mhm,
be, because I see a lot of that in PySpeed, and I don't believe that's a solar physics kind of thing. You see that? So trying
mhm,
to, like, if someone's trying to do an analysis where they need a software that will generate power spectra,
mhm,
because that's
right.
I
Mhm,
imagine that to be a common search,
mhm,
something that someone might look for often. So
right.
I'm not trying to dive into like all the different types of things, but some common things that someone might see that and say, yes, that's what I'm trying to do. What do you
Mhm.
think?
Yeah, no, that would, uh, I think that makes sense. Yeah, identifying some of those key search features that
Do
people
you
want
have
to
any
find.
ideas of something that we're missing here? Like something that's pretty
I'd,
common?
I'd have to think about it, but yeah,
That would be great.
XT plots or something, line
Okay.
distance. Yep.
Wait, what was that?
Well, yeah, time and distance, or yeah, uh,
Those are
plots. Yeah.
I mean, I know I have a
Mm,
physics background, as
mm,
many of you do too, but I
yeah.
feel like that's almost too basic to pull in.
Uh, mhm.
Am I wrong on that? I'll take silence as a no,
Yeah.
I
Mhm,
guess. Okay.
mhm.
Okay. Yeah, looking for input here. We're at time, Julie. I know you have to move on to the next thing, but hopefully we can get some more feedback and more discussion time in the telecom coming up.
Definitely. I haven't yet put the following telecons on the schedule, but
Okay.
we'll chat and see if either next Monday or the one after works better for you for that to make sure you can also be there. Cool. Well, thank
Would
you,
you like
everyone.
us to keep this document open and maybe after the meeting, keep adding suggestions here? Or should we
Go
just?
for it.
Okay.
Go for it. Yeah. I will leave leave it all open for you.
You can't see my fireworks.
I see your fireworks. It's
Yeah,
blurred out, but it's there.
Muted. Okay, you can see the confetti comes in front of your face, so it's a bit better. Oh, balloons. Anywho, cool. Yeah, we'll continue this discussion at further telecons. The background for all this is a little extensive, but now you all have a good base understanding. So when we hop on the telecon, it should flow a bit quickly. Cool. All right.
Sounds
Well,
great. Thanks.
yeah, I'll see you all tomorrow. Same time, same place. I don't have the agenda pulled up right in front of me, but I know there's going to be some FEP discussion, GitHub Zenodo connection, discussion and overview, etc., etc. So come there, be excited, and I'll see you then. Thanks, everyone.
Thanks.